everyone, welcome back to channel Code with AKJ. Today is day 12 of solving LeetCode 75 challenge, and today's question is container with most water. So here the question says you are given an integer array height of length n, and there are n vertical lines drawn such that two endpoints of the ith line are I comma 0 and I comma height of I, and we need to find two lines that together with x-axis from a container such that the container contains the most water. We need to return the maximum amount of water a container can store. So given example here, given heights in the form of integer array where heights are 1, 8, 6, 2, 5, 4, 8, 3, 7. Here they have given an explanation that the above vertical lines are represented by array, and in this case the maximum area of water these vertical lines can contain is 49. So let's start with our brute force approach. So in our brute force approach, we'll try to check every possible pair of lines and we'll try to calculate its current area. And we know that to calculate area, we need height and width. Here the height would be the minimum of both indices I and j, and width would be the difference between them, that is j minus I. So we'll calculate the current area, and we'll also keep track of the maximum area by taking an external variable max area, which would be initially the least possible value, that is int min in our case. So in this way, using two for loops, we'll check each and every possible pair of lines, and we'll calculate its current area and we'll compare it with max area. And finally, we'll return that max area. So here our time complexity would be O of n square, as we are trying to check each and every possible pair of lines, and space complexity here would be O of 1. So let's try to code this approach and let's submit. So here's the code for the brute force approach we have discussed. Here I've taken the max area variable, which would be initially int min. I've taken two for loops which will check each and every possible pair of lines. I have calculated the current height value, current width value, also calculated the area, and I compared it with the max area, and finally I've written the max area. So let's try to run this code. So let's submit. So as you can see, this approach gives us time limit exceeded, as this approach works for smaller inputs, but it has a time complexity of O of n square, which is inefficient for larger inputs. So let's optimize this with our two pointers approach. So here's the idea is simple. We'll start with two pointers, one at the beginning and other at the end of the array. We'll calculate the area formed by the two lines at these two pointers, and we'll move the pointer pointing to the shorter line inward because the area is limited by the shorter line. So based on our current area value, we'll try to move both pointers I and j respectively. So let's try to understand our optimal approach using an example. So let's try run our optimal approach using this example and understand our optimal approach and how it works. And finally, we'll code that approach and analyze our time complexity and space complexity. So I've taken this example where the height values are 186, 254, 837. We'll take two pointers. One starts from the starting point of the array and one starts from the ending point of the array. So as we know, we'll have to calculate the area covered by these two lines, I and j, and we'll compare it with our maximum area variable, which would be initially 0, or the least value we can take is int min. So the height would be the minimum of these two lines, which is 1 here, and width would be the difference between these two lines, that is it is present at index 0 and this is present at index 8, so width would be 8 here, and area covered by these two lines is 1 into 8, which is 8. So we'll compare it with our max area value, and since 8 is greater than 0, we'll update our max area value with 8. When we try to move these pointers, we need to make sure that it should cover a lot of water inside it. So we need to compare the heights of these two lines, and we need to make sure to move that pointer whose height is less. So when we try to compare the height of these two lines, we can see that the height of the line present at index I is less. So we'll try to move our I pointer to the next index, and we'll again calculate our height and width and our area. So here height would be the minimum of 8 and 7, which is 7, and width would be the difference between these two indices. So difference between 1 and 8 is 7. So here the area is 7 cross 7, which is 49. So now we'll compare this current area with our max area, and since 49 is greater than it, we'll update our max area with 49. And again, we'll try to move these pointers. We'll check the height of these two lines, and since the height of j is less, we'll try to move our j pointer one step backward. So in this way, we'll calculate the current area and try to compare it with our max area. So in this way, we try to calculate the current area and compare it with our max area variable. And finally, after finishing this loop where I crosses j, we'll try to return our max area value. So let's try to code this approach and analyze our time complexity and space complexity. So here's the code for our optimal approach we have discussed and dry run using this example. So here I've taken the size of our height vector and store it in variable n. I've taken a maxi variable which would be initially int min. I've taken 2 pointers which would start from the starting of the array and one would start from the end of the array. I've used a while loop where until or unless these 2 pointers cross each other, we'll try to calculate the area and we'll compare it with our maximum variable area. So height would be the minimum of both two lines heights and breadth would be the difference between these two indices. We'll calculate our area and we'll compare it with our maxi variable. And when we try to move our pointers, we'll try to check whose height is less than the other. And finally, after finishing our while loop, where these two pointers crosses each other, we'll try to return our maxi variable. So let's try to run this code. So let's submit. As you can see, this approach gives us successful submission. Time complexity for this approach is O of n and space complexity here is O of 1, which is significantly better and faster than our brute force approach. So let's try to analyze the time complexity and space complexity of both our approaches. So the brute force approach takes O of n square time in time complexity and space complexity is O of 1. And our optimal approach where we have used 2 pointers approach takes O of n time complexity and space complexity O of 1. So in this way we have optimized our time complexity using our 2 pointers approach, which is suitable for larger inputs as well. So that's it for today's problem. We saw both brute force and optimal approaches highlighting how to improve the efficiency of our solution. So if you found this helpful, don't forget to like, share and subscribe to the channel for more coding challenges. See you in the next video. Thank you.